Hello, good morning, everyone. This is Shubhrojyoti Maitra from from LMAX System and Solution. I am the application engineer of LMAX System and Solution. So today I am going to discuss on the segmentation of ECG signal using deep learning technique. Okay, using the software MATLAB and Simulink. So here you can see this is the example of segregating the waveform using deep learning technique. So at first, what you have to do, we have to load the dataset. Okay, this is the first and foremost step. So as you can see here, how to load this dataset, we can download it from the URL. Okay, as the URL is provided here, we have to mention the full path of the URL. Okay, and when we have set the name of the URL, that is data URL, we can we can create a temporary directory for the data. Okay, where the dataset will be temporarily downloaded and saved. Okay, so basically this is the zip folder. So after unzipping it, we can visualize the complete data set. So in order to unzip the folder, we have to use this command that is called unzip. Okay. Now second step is the creating a signal data store. Okay. Signal data store means actually it is a container where we are going to save all the data set in a segregated manner. Segregated manner means what? We Once you open the data set, you can see there are two attributes we have in the data set. One is the ECG signal magnitude, which is named as ECG signal, and second one is the region levels. Okay, region levels means ECG signal has different regions of levels like T, EQR, P, R, and so on. Okay, so these regions are separately saved or separately stored in another container so that the values and classes or regions cannot be mixed with each other. Okay, so that's why we have to use a signal data store command here. Basically, we generally use it to save different data, like whether it is belongs to the signal class or image class. Okay, in order to store the image data in this format, we can use the image data store. Okay, right now since we are using a signal here, that's why we have to use this signal data store command. Now since the data is a very large data, we have very large number of samples we have in the data set, 2,25,000 samples. So we cannot visualize the total data. Okay, so we have to we can only visualize the first few samples of the data. As you can see here, in order to visualize that, we have to use the head command. Head and tail is basically used to visualize the first few columns or first few rows and last few rows or columns of the data, or the big data basically. Basically, this technique is used where the big data are there. Okay, whenever we are dealing with the big data. So here, since the data set is very large and its volume is very large, very complex data set, we cannot visualize the complete data. We are using head command here. Okay, now we will not classify the whole data. We are not using the whole will not use the whole samples of the data, that all the samples that already provided in the data set, that is 2,25,000. We will only use the 1,000 number of samples which are available for the from the first few rows or first few columns of the data set. Okay, in order to do that, we have to create we have to use another function that is called signal mask. Okay, and the plot seek ROI function basically give you the information about the plot or the plotting of a signal, keeping the ROI mentioned beside of this plot. Okay, so as you can see that the ROIs are already showing with the data set. Okay, the data set is the plot is already showing here. The plot is the plot of ECG signal. As you can see, this is though the complete data is not plotted here, only 1,000 sample is plotted, and with this sample of plot we have already we have also showcased the classes or regions of the data. Okay, that is a P region, QRS region, and T region. Now after that, what you have to do in order to before going to train your machine learning model or deep learning model, you have to segregate the data set in a uh, two separate directory or two separate folder, you can say that. Okay, two separate category. One is called the train category, one another is the testing category. So in the train category and testing, why this is required? Because whenever you are going to train your model, if you use all the data for training, once you test your model after going to the, after train your model completely, you will get the same result. You cannot visualize that, you cannot segregate your model between testing and training. Okay, you cannot understand whether my model is perfectly operating or not. So to avoid this confusion, you have to segregate the data set between training and testing phase. So this is the general norms or the trends that we have to use 80% of the data set as a training, and 20% remaining 20% will be used as a testing. Okay. Now we are using a divide rand function in order to perform this operation, training and testing segregation. Okay, segregation of the data set between testing and training phase. After that, we are using the get mask function. Actually, this function is available in our. I'm showing you. Actually, this function already developed by us in the MATLAB. You can see the get mask. Okay, this is another function. Why this function actually developed? This function actually developed in order to uh, have the fourth class, because fourth some data are already there which are not belongs to that three classes, that is T, P, Q, R, S, and so on. So that's why we have to use a fourth class also, and the fourth class we have named here as a not applicable. Okay, NA. Now after doing this, we are allocating the training and testing data to this get marks function. Now we are using the resize data also. Resize data. Resize data is, it is also a function. This is also the function we have developed. Why this function is developed? Because of the fact this data is not initially fitted with the model. Okay, initially it is not fitted with the model. That's why we have to resize the data set. Now what model, machine learning model we are using? We are using LSTM model. Okay, LSTM means what? Long short term memory. So you can visualize from here that this is the long short term memory. This is the long short term memory. This is the variant of your recurrent neural network. Basically, recurrent neural network uses the past information to classify your data or classify your model. Okay, so as you can see, this is the some modification is done with this RNN structure. I will not go into the detail. If you want to learn more about this RNN or LSTM, you can read books. I have the book I can share, or you can directly go to the website. Okay. So we are using LSTM network. This is the command that you have to use here in the MATLAB. You have to use LSTM layer, sequence input layer, fully connected layer. These are the basic command that you have to pass here in order to form this network. When you are forming the deep learning network, you have to use this command: sequence input layer, fully connected layer, softmax layer, classification layer. Okay. Uh, After doing that, you have to set the parameters for training. We are using SGDM, that is stochastic gradient descent search algorithm, for the training operation. We have set the maximum epoch equal to 10, and the batch size 50, and so on. Other parameters you have to set here. After doing all this thing, you have to simply train your network. Now before going to train, since your data set is very large, you have to use a tall command. Okay, tall is actually used, it is used when we are basically deal with the big data set. So tall command is used for both training and testing data in order to avail the first few columns or first few rows of the data to feed it to the directly to the network. Okay, neural network. Now after doing that, we are using the train command, train network command, to train your network. So as you can see, after doing training, you will get the information here, whether what kind of accuracy it is showing and what kind of loss percentage it is showing. After doing that, you can classify your data. Now you can directly visualize this from here. This is the confusion chart, that all these four classes are there: P, Q, R, S, T, and the not applicable that we have already taken. So you can see that on a 40% data is belongs to 40% signal part of the belongs to the P class, and QRS class belongs to 2.6% of the data, and remaining 0.9% data is belongs to T class. Okay, and remaining part is